All right, so today we're going to take a quick look at the Industry 4.0 revolution. And we know there was just, it was an amazing panel discussion. Hopefully you guys all saw that. It was actually quite interesting to me. Then we're going to take a look at enabling technologies and then a few example applications for Industry 4.0. Is this working? So before launching Zemelgo, I actually worked at Hitachi, and I had the privilege of traveling the world and sort of seeing what's going on in different countries. And for me, it was just amazing. Like they were saying at lunch, many of these countries have moon missions, where the countries are actually investing tremendous amounts of money into manufacturing, basically subsidizing their manufacturing sector and really aimed at the United States, right? Working to sort of leapfrog us and to sort of take some of our markets going forward. Excuse me. But obviously Germany, they have Industry 4.0, China, Made in China 2025. Japan actually has Society 5.0. And then there's a whole bunch of others, again, around the world. And then I love this quote from Elon Musk. It's really on us as a manufacturing community to sort of like double down and sort of like understand what's going on around the world and to start to apply technology in a way that helps us, to again, maintain our lead, if not, progress even further. So one thing, a lot of manufacturers, they have a hard time understanding, what is Industry 4.0, like what's actually going on in the market today. And so one interesting way to think about it, it's really an extension of the digital revolution, right? And so digital revolution, which I'm sure everyone in this room is aware of, it was sort of moving from a computer on every desk, to a computer in every home, ultimately to a computer in every pocket, and now we're moving to a computer in every machine. And that's really sort of what Industry 4.0 is starting to make manufacturing, factories smart and actually make the products themselves smart, right? So just sort of bringing these things to life. And again, it's just going to continue on and on and on. There will be a time where every single machine has a computer inside of it. It all has software running on board. It's connected, to the internet. There's data streaming in. And then we're doing interesting things with that data in terms of, how do we make this machine more efficient? How do we make it safer? How do we make it more functional? And it's going to be interesting where our machines actually start to get smarter and smarter and smarter over time. And so we're moving, again, from last century where the machines were dumb and you'd have to visit them to understand sort of their current state, to this new century where machines are, again, brought to life through software. They're intelligent, and we can monitor. We can wake up every morning and we can basically monitor all of our machines out in the field across the whole world and see their current state in terms of how they're doing and when they need maintenance and replacement. And so like we said, last century, and again, as part of that panel discussion, Tom Kelly said, that Detroit or Michigan actually led Industry 2.0, and that never occurred to me. So for me, it was like, wow, holy cow, he's right. And again, for Industry 4.0, it's sort of up for grabs at this point, right? But the one thing we know is again, last century, electricity brought our factories to life, electricity brought our machines to life, and that was really sort of what powered, again, that Industry 2.0 revolution. In this century, software is going to bring factories and machines to life in entirely new ways, right? And so software is sort of the new electricity, for this century and for this revolution. And there's a lot of quotes out there where people are saying, operating without software is like trying to operate without electricity, right? That's how important software is becoming to our manufacturing capability and to our machines going forward. And then, when we launched Zemelgo, we sort of took a look at what was going on in the industry, right? And a lot of manufacturers, will say, why should we do this? We're operating perfectly fine. I don't understand the need for technology. Again, I think, we're leading in our industry. There's no need to look at these things. But again, if you look at retail, like Amazon started with a very simple website selling books, and then they proceeded to apply technology to every facet of the retail operation. And now, obviously, they've completely disrupted the entire retail space, right? And this is a 25-year journey, right? 25 years ago, again, it was just, again, a simple website selling books to now, you can order on your phone, you can order on Alexa. They have robots, basically driving their logistics, facilities and so forth. And so we actually see manufacturing going through the same exact journey. Again, it's a 25-year journey, but every single manufacturer needs to start, with their simple website selling books, right? You shouldn't try to boil the ocean or solve, the entire challenge like right out of the gate. Again, it's a journey where you make some very, sort of targeted, investments, and then from there, you can start to learn and apply those learnings again through the course of your journey. And as we'll see, that's sort of how Zemelgo has been designed to basically make it super simple to get started, and then basically add more and more capability at your own pace, across your operation. But again, hopefully this resonates for everyone. There's a lot of, you can see on the slide, there's a lot of big brands that thought they could ignore the internet, and they thought they could ignore e-commerce. And again, it wasn't immediate. They didn't go out of business instantly, but 4 or 5, 10 years later, they were basically in a position where they couldn't get there from here, type of thing. And that's why it's just so important that all manufacturers, start to make these investments and start to, basically, gather those learnings and apply those learnings. The other thing that struck me, and again, I don't know if everyone's aware of this, but industrials actually have the lowest revenue per employee, right? And so to me, that just screams that this is like a very human-intensive operation, and we're not applying technology, to make our factories more efficient, to make our operations and even our aftermarket, services more efficient. And so again, we need to start applying technology to make the humans that much more productive, right? And again, make the products that much smarter, and again, make the products that much more long-lasting going forward as well. But again, really interesting sort of statistic to take a look at. The other thing that we've learned personally, so again, we deal with a lot of manufacturers. I think I mentioned I'm based in Seattle, and so we work with a lot of aerospace manufacturers. And one thing we're seeing right now is a lot of people leaving manufacturing. A lot of the workers are leaving manufacturing, and a lot of them are ending up at the Amazon fulfillment centers, right? And some of that is technology. You walk into the Amazon fulfillment center, it's like a technology playground. It's a technology wonderland. Then they go back to their basically factory that they might have been working at before they accepted the job, and it looks like it's in the Stone Age, right? There's not a lot of technology. And again, they're being forced to do menial tasks like cycle counting inventory. You have to shut down the facility and go count all the items. Or maybe things are constantly getting lost and they're having to walk around for hours looking for a misplaced order. They also find chemicals are expiring and having to scrap those and so forth. And so again, we're starting to look at technology. It's not just making your life easier as a manufacturer. It's actually becoming a retention and recruitment type tool for you as well, right? And so a lot of our customers are starting to think of it that way. And so if we dial this back to apps on the factory floor, there are 4 enabling technologies that make these applications possible, and they are cloud, mobile, AI, and IoT. And we're just going to take a sort of a quick walk through these, right? And so before cloud computing, a lot of the software is running under someone's desk. It's running in an IT closet. Very expensive. You have to have people on site, to manage these things and protect them. Make sure that they're secure. Constantly upgrading them and so forth. And again, so cloud has just made deploying software in a factory super simple, right? It's almost like Gmail or Google Maps. Everything's online. You just connect into it, and it's basically protected and sort of upgraded and secured for you. And again, just making it much easier to deploy software solutions. And again, we've seen this over and over, where people, we've seen some people, IBM PCs, really old legacy PCs, DOS applications, running their factory on spreadsheets, and sort of cutting and pasting and emailing the spreadsheets, around to the other team members, and everyone's trying to, make edits and everything. And again, we can turn all this into an app, like a multi-user app. It's in the cloud. Everyone can access it, in real time or on their mobile device. And again, not having, to basically email these things around to everyone. And then mobile, a lot of our customers early on, they were telling us they just don't have time to go back to their desk and open up the ERP system and run some complex report and sift through all the results, to find what they're looking for. They're just constantly on the run. They're putting out fires on the floor. They're talking to vendors about raw materials. They're talking to candidate customers about new opportunities. And their day's over in a blink of an eye. And so they didn't have time to go back to their desk and check the status on things. And so they were telling us, I just need the data coming to me. I need it, pull out my phone, be alerted, when issues are popping up, be able to check the status of a hot order. When the customer calls, I shouldn't have to run out into the floor and find that order to figure out where it is in the process. I should be able to see it, on my mobile device, exactly where it is. I should be able to see the ETA of when this thing will be complete. And I should be able to, basically respond to the customer in the moment. Again, a lot of our customers would run out into the floor, basically look for it for 30 minutes, and then they have to craft an email response to the customer. And again, we can shrink that time. Again, make everyone's life a whole lot easier. And then AI. The other thing we've seen is the schedulers. The schedulers at manufacturing plants, they seem to be the most stressed out people. They spend hours putting together this masterpiece of a schedule, and then 5 minutes into the day, it's invalid because the customer called and changed the due date, or a worker called in sick, or a machine went down, and yeah, now that schedule, as perfect as it was at the beginning of the day, is now like out of date. And so again, AI, we can basically compute that schedule 50 times a day, right? We can just constantly be updating that schedule. And we look at it, just like Uber is able to map like a driver to a passenger, we think the software should be able to map the work to the worker, right? And so when I'm done with this work order, the software should tell me exactly what to work on next, taking like everything into account, again, across the entire operation. And then IoT, right? So the Internet of Things. Before IoT, again, you'd have to visit everything, right? You'd have to visit your inventory so you could basically count it all. You'd have to visit your machines so you could tell the current status of them. You'd have to visit the work orders, to see where they are in production. And so with IoT, like everything's getting connected, right? And so now the data is coming to you rather than you having to go to that item, right? And so the best way to think about IoT is it's really automating the data collection, right? So instead of the human having to do that data collection, the data is like streaming into you automatically. One second here. All right, so again, the applications that we're building for the factory basically pull all of these technologies together, right? So cloud, mobile, AI, and IoT, again, coming together to provide very pragmatic applications for the manufacturer. And so in terms of examples, right, and so, again, we say to start small, right? Start with a pain point in your factory, and then from there, start to roll out that solution, over different functions, right? So inventory, work orders, finished goods inventory, shipments and so forth. There's really sort of an app for everything, right? And again, you can start to roll these out at your own pace. But for inventory management, this is really building like an Amazon Go style capability for your inventory, right? So workers should just be able to go into the stockroom. They should be able to go into the warehouse. They should be able to grab what they need. They should be able to walk out. They shouldn't have to move a Kanban card, from one bin to another. They shouldn't have to look to see if it's the last item. The inventory manager shouldn't have to do a lap around the facility, pick up all the cards and order things. Again, we can digitize and automate all of this, right? And so with this type of app, the inventory manager has real-time visibility, to what's in the stockroom, what's in the offsite warehouse, what's at all of the different locations. They can get alerted if inventories are running low. You're down to your last 2 pallets, or you're down to your last 5 crates, or you're down to your last 10 items. We can actually give recommendations on how much to reorder, right? So watching consumption, looking at the orders that are in the queue, we can basically make a recommendation on how much to reorder to get back to that optimal level from a replenishment standpoint. And then also just being alerted for scrap, right? If chemicals are expiring, in the back of the warehouse or whatever, again, you can get those alerts and you can be able to find those pretty quickly. And then in terms of inventory and cycle counting, with RFID, there's actually a handheld reader. You can just go into a warehouse and you can basically scan everything. It'll really synchronize like what's in that warehouse with what's reflected in the system. And so again, rather than having to manually barcode scan or manually visit every item, you can just, again, do that in a matter of minutes very, very quickly. For work orders, again, this is another issue where customers just didn't have visibility to where the work orders were in the production process, right? And so we know everyone has ERP systems or some way to capture that. But there's a lot of workarounds in terms of backflushing the ERP system where you update it at the end of the day, or in some cases they update ERP once that order crosses the finish line. They'll just basically update the whole ERP system. And that makes the worker's life easier, but now it's basically creating blind spots in the operation for the leaders, right? So the leader can't just go into ERP now and see exactly where the orders are. Again, with our solution, with sensors and with the software, we can basically track every single work order flowing through production. We can give you alerts when bottlenecks are developing. So if orders are piling up in one department, you can just get an alert on your phone. There's a backup in QA, or maybe the production line, there's a gap in the production line. Also, if orders are stalled, you might have a hot order sitting in one department for too long, you can get an alert. This critical order hasn't moved in an hour. Is that an issue? Should the leaders jump on that and make sure that's moving again? And then also misrouting, right? If an order gets dropped off at the wrong work cell or the wrong desk, you can get alerted for that, right? Because it might just sit there because no one's expecting it to be there, and now it becomes a scavenger hunt, to where did that work order sort of land. And again, so yeah, these apps are becoming very, very popular with a lot of the manufacturers. So the other two assets, and this is pretty much like Find My iPhone for the factory, right? And so blueprints, calibrated equipment, chemicals, these things, carts and racks, get scattered around the facility. And again, just being able to pull up on your phone and type in what if you're looking for a blueprint or you're looking for like a cart, be able to see exactly where that cart is in the facility. And so also, being able to push the maintenance schedule into the app as well, right? And so being alerted when tools require calibration, and then basically letting the maintenance team know exactly where that tool is, right? And so before Zemelgo, a lot of the maintenance teams would basically print out a spreadsheet and they'd be walking around the factory. Has anyone seen this? Has anyone seen that? And it's really a scavenger hunt, looking for these tools. And again, now with Zemelgo, it's an instant notification along with exactly where that item is, right? So very, very simple to go pull that off the floor, do the calibration, and then sort of redeploy it. Same thing for chemicals. I mean, we've had customers in aerospace, saying that they're losing $1 million a year in chemicals that are expiring on the floor, right? And so again, we can track those, we can alert them before they expire, and that allows them to load balance them, to a different work cell where they can start to get deployed, again, rather than scrapped. And then another one that's become really interesting lately is like geofencing, right? And so obviously tools get borrowed, like from one work cell to another. And with geofencing, you can basically get an alert if tools are leaving their home base, right? And so if a tool is being pulled from a cell, that can be an alert. Or if a tool is seen at an exit, maybe that's a loss issue where it's getting ready to walk out the door, again, you can get an alert on your phone. The security team can get an alert and sort of capture that as well. All right. And then for shipments, we've had a number of manufacturers where the work will flow between the facilities, right? And so they do manufacturing in one facility, they'll do painting and coating in another, and then final assembly and QA in the third. And sure enough, 100 orders leave facility one, and then whatever reason, 95 arrive at facility two. And the challenge that our customers were facing is that they wouldn't realize the 5 orders were missing until a week or two later, right? Because they would receive those parts, they'd put them in the corner, then 2 weeks later, they're finally ready to work on it. They open it up, and it's missing 5 things. And at that point, it's impossible to figure out where those 5 parts sort of landed. And so again, with our solution, we create sort of a digital audit trail. 100 things left, 99 arrived. If there's a gap, everyone gets an alert on their phone that something might have been left on the truck or dropped off at the wrong location. And it's much easier to resolve that in the moment than to try to resolve it again a week or two later after it happened. All right. So I think with that, we want to do a quick demo and basically showcase the solution for you.
Hope it works. Can you guys hear me?
I will step down.
Can you hear me now? Okay, thank you. So as we were talking about providing some slides, I said, let's do a live demo for the solution we provide. This way, kind of you see firsthand how sensors work, how parts move from one zone to another zone, and pretty much get a live feed to every single part that's moving through your facilities. So what we did here, we have a map of location, and we have 3 different choke points to that location. We have a reader here, which is zone 1. And then I have another one here that is zone 2. And then also the exit door, which is zone 3. So you can see there are different readers. This is just depends on the area. Some readers don't need to read a lot of tags, or they need to use short distance. Also, we have for long distance up to 50 feet. So we kind of adjust to the environment. RFID for itself, it's technology that has been around for quite some time, so it's not something new that we are inventing. We're just using that to improve your process. We're not trying to change the process. We're just trying to improve it where it lacks speed. So what I'm going to do is I have a few items that I have created, and as I said, RFID, it's obviously very sensitive to metal and water. So 10 years ago, For example, there were very, very few items that you can protect because the RFID wasn't ready yet. Since then, the technology has improved, and now we have tags for metal, we have tags for water and liquids and acid and all kinds of different materials. So that challenge has been passed. And also, the cost of tags and readers has gone tremendously down, where 10 years ago, for example, a tag might cost $1. Now weight is probably 60, 70% lower than that, so it's easier to implement. I have, if you can scroll down a little bit. So if you can see here, I have tagged a few items, and these are plastic, and also I have like some kind of a GPS tag that has PCB boards inside. And then I have another item here that is really metal. And you can see I have a tag on it, completely metal. So technically, 5 years ago, I wouldn't be able to detect this material. Now I have no problem detecting any kind of material. And then the last two ones, I'm kind of pretending to be an iPad and plastic and all kinds of different materials that we have. So the first test I'm going to do is, this is the iPad. And you can see that in zone 1. And then the time. So this is zone 1. I'm going to zone 2. So as I'm walking from one zone to another zone, and the reason I'm getting close here is because I lowered the power, so I don't have mixed zones. So if you can refresh that, and then you'll see the item got red to zone 2. So immediately, as I move from one zone to another zone, it scanned, and it gave you a live feed of where that item is leaving. Now, I'm going to turn on my phone for the text message, and if I leave Can you refresh that? Yeah, click there. So you can see now exit door, and that will alert me in text message, and also I receive an email at the same time. So immediately as I left on zone 3, something is leaving the geofence, you will get an immediate alert on your phone. Here you go, I just received it. I had it on mute, I'm sorry. So this is kind of a simple process. You can have choke points at the doors. You can have a geofencing, meaning that one zone can be selected, and we put readers from different sides, from bottom, from top, from the sides. We control that geofencing. So any tool, any equipment that leaves that zone will notify you immediately that left that zone. When the process moves from one station or one desk to another desk, those can be also monitored because we use what we call near field antennas that can detect only a few inches on top of the table. So there is no confusion between desks, even desks that we can read only a few feet, a few inches. So you can track the process in a large scale from one building to another building, or you can track from one zone to another zone, or even from one desk to another desk that are close next to each other. So that's pretty much, and if you go back to the scroll down up, the zones, you can see now that you have 4, 2, 1. So technically, right on the map is giving you the count of each tag that it's going from one zone to another zone. And again, I got the text message. I'm going to leave with another item. And I think that it has something to do with building here, because my phone, it's been having kind of a little delay. So I just received another message. So technically, a text message will be within seconds. And there you go. And then also the email at the same time. So we can define whatever you want to be notified. You can have big monitors that show the status, Or you can have even bells and whistles, just kind of give you the process as far as where the zone is and what's leaving and what's coming in. Again, as Rich mentioned, that obviously you want to monitor the status of a product, if it's expiring, or if it's missing. These are all kinds of things. The RFID technology, it's not complicated. As long as the sensors are reading the tags, the data is very, very simple. Then what you do with that data, it's kind of a rich what you get back. Because you might start to detect something leading from one zone to another zone. But then as you get data, you realize, wait a second, this zone is taking 5 minutes to finish something, but another zone with the same exact process is taking 15 minutes. Why is that discrepancy? That data that you receive gives you a better understanding of your process. It says there's something wrong on that second zone, that they're doing the same thing, but based on this data that you're receiving, you go to the next step. And that's where AI comes into play, and then improves the process because of the technology. The simple process that you wanted to achieve goes to the next level. And as you can see here, timestamps, obviously they are quick. Again, everything relies on IoT, so IoT, obviously internet connection, which nowadays is very available. I have a 4G modem down there that is running everything. So all I have is a 4G modem that I have these sensors plugged in, and that's a web-based application. And gentleman over there, I came here, 2 minutes, I explained to him what to do, and he's running it from me. So he doesn't work for us, so he's there. So he's running it from me right from there.
All right.
Thank you.
Any questions? Any feedback?
Can your readers do zones, or are they one reader per station?
You can have multiple readers. You can do, pretty much the software drives it. Hardware, you can install as many readers as you want. And then the software drives that, and you can define what that zone is and how many readers you want on that zone.
Okay.
Yeah, there's a lot of different kinds of readers. Like there's dock door readers, right? We can track raw materials coming in or finished goods going out. There's bigger readers that can read like 30 feet, in a very complex area. And then these readers are more for like a choke point, like a doorway or like a work cell, like you're suggesting. There's also a handheld that you can walk around and basically find missing things with as well.
So how far the distance you can catch through this system, and plus, what about the security? Like an intruder can block you and can do things. How secure it is?
So the readers, the RFID, we're using passive tags, and so they're not powered by a battery or something. So that the limitation are up to 50 feet. You can read any passive tag with very strong readers and antennas. That's a passive tag. As far as the security goes, every chip that is on these antennas can be password protected and locked, meaning that if you're writing to that tag, that information, as long as you define what the process is, there is no way for somebody else to read that tag and change the information or do anything. It's like anything else. Everything is password protected. And then there are like 96-bit chips. Now there are longer ones, bigger ones, and better ones. So it depends what you want to store in that information. The information that you store on the chip itself, it's kind of I would say, very limited to what you store. That can be a work order or can be some kind of information. And then when it gets read by the reader, that information coming from the sensor, from the tag itself, the data understands the rest. So as long as I'm sure everybody uses EasyPass on your cars. So when you go through the tolls that have EasyPass, those are RFID. Those are just the EasyPass tag that you have in your car is active tag because it has a battery inside. It's the same process. Every car has a tag, so every time it moves out, the reader is seeing the tag, and then now the EasyPass is charging your credit card for that pass. So it's a kind of a information that is stored on a chip and is secure because you can obviously define what the security is on a chip itself. Then the readers is, again, passive tags are up to 50 feet.
Yeah, and so I just want to chime in a tiny bit on that too. And so we work with a lot of DoD and space companies like Blue Origin and Collins Aerospace. And they leave a lot of the sensitive information in the existing business system, right? So the ERP system, all of the sensitive data stays in there. And just as Tani's suggesting, all that's on the tag is like a cryptic ID. And then Zemelgo, our software, maintains the relationship with that cryptic ID and the ERP sort of record. And so again, so there's no sensitive data going over the networks. And I would also say the readers can be calibrated, like you were asking, right? And so there's like a power dimension and a cone dimension. And so you can turn it on full blast, or you can really focus it just like on this table. And so it's very flexible.
Good afternoon.
Hey there.
I noticed there was a lag time that you were saying was a condition of this building. What makes this building different than a manufacturing facility? Is this aiming, a fine-tuning of the system that you haven't done here?
First, I'm using a 4G modem, which is pretty much, obviously, as fast as it can get. That is, every time I'm going with a tag, that connection is slow, pushing data to the cloud. That by the time the cloud gets the information and sending the text message to you, that takes a little bit more time. So it's a process going. Now, obviously, if this reader was connected to a LAN connection, the speed is not a problem. I would say probably 100 megabytes per second. Everybody has it at home now. So that is faster.
Yeah.
So
and it was still almost a few seconds, like let's just say 10 seconds, but it's again, I think like Tani's saying, it's really interesting, that reader is connected to that modem that's connected to our software in the cloud, that's detecting this item, then he's getting like an update like on his phone. Yeah, that round trip.
So it's a matter of internet bandwidth.
Yeah,
The
the
situation
connectivity,
here.
absolutely.
Yes.
Yep.
Thank you.
In here?
Usually shows, since there are so many people in the same location and so many Wi-Fi's also in the same building, radio frequency, we're using radio frequency, RFID. It's just a different frequency. Cell phones, Wi-Fi's are kind of, I would say, in the same range. So the more people you have together, that's why stadiums, for example, they have their own Wi-Fi networks for Verizon or AT&T, because it's impossible for everybody to get signal. And that's why. I mean, it's just a matter of technology. IoT, it works.
Yeah.
Delay, you can handle delay.
But it is interesting, like our software is running, just like you said, cloud, mobile, AI, and IoT, like our software is in the cloud, we have the IoT sensor, you have the mobile app on your phone, and then the AI comes into play in terms of, again, tracking like where these things are and making sure you have enough of the assets like in the right locations, based on consumption. So, good question though.
Just need clarity on the RFID tag itself. Is it just have a serial number, or you can actually program it and put whatever you want on it?
Yeah,
what
you can.
The process
So I mean, it's a
like?
great question. So the tags, like a lot of our customers, they're already using barcodes, right? And they have a Zebra printer, and they're spitting out barcode tags that have the barcode and some human readable information. And yeah, so you can, in a lot of cases, you can just swap in a new printer, and now that same exact tag has the antenna and the chip, and then in terms of what goes on there. Like again, we try to put as little as possible, but we can also put as much as possible. Like if the customers want to put more information on there, like you're sort of suggesting, in some cases the parts might flow from you to your partner, and you can actually embed some information like in that tag, where now the partner can sort of auto discover that item, and then do something interesting with it, right? And so a lot of our, if I can just drill a bit deeper. We power a lot of VMI solutions out there, so vendor managed inventory, where our distributor will tag all the chemicals and they'll tag all of the tools. And then once they're taken out of stock, out of inventory, they're now on the floor. That same item goes from the vendor managed inventory solution now into the customer's version of Zemelgo, just like you're saying, because there's some information on that tag where we know sort of what that thing represents. And so yeah, so you can definitely put different information on there.
As much as, though, I mean, it depends what the tag wants. Obviously, there are different type of tags, 96 bits, 256, like they are different ones. They are coming out with a bigger one that they just really can store as much as you want. Obviously, that has to do with the pricing also because, you know.
One of our customers is like tagging their items. This is an apparel manufacturer, tagging the clothing coming out of their factory, and then they ship it to the 3PL. They have readers at the 3PL that basically auto-discover what those items are based on the tag. And so that enables them to know how much inventory the 3PL is holding on their behalf without again, having to cycle count it all. Yeah. Oh, sorry.
An example of discrete information. And what if you're handling something that is a bulk handling and then it goes to a process where you're going to consume so many ounces or
right. Okay, so that's
and then goes back into inventory or you know what I mean?
Yeah, so there's a lot of different ways to do that. Like it's a great question. If people pull out a handful, or if you cut something. So the software and the sensor can detect maybe how many pallets there are, or how many crates there are, or how many boxes there are. But if you want to get into like how many items were pulled out, we can do that with the app on the phone. So the worker can basically scan the box that they're pulling from and say, I just took 5 of these or 10 of those. Or if it's a liquid, they can say, I just took 50% of this, right? So again, at least today, that's where the human has to give us some of that information. And again, because the tagging can happen at any level you want. And if you're talking about small items, you're not going to tag like all these small items. And so again, that's where the human sort of has to come in and tell us how many they took.
And our approach is to complement your process, not to change it. So we don't want to come here and say, okay, your process doesn't work. Use our software, we'll do everything for you. No. We are trying to implement the technology to kind of improve your process where it's lacking like speed and accuracy. That's what we try. We try to, okay, you're going to do the same process, just faster and better. Then if you see from the data that your process need to be changed, that's your decision, not ours. So you use the data to make the decision going forward.
Great questions.
I just wanted to say something about the unique serial number on the tags. We do a lot of work in retail and supply chain and other aerospace. I always use an example that the RFID tag serial number, EPC, is like a VIN number in cars. So I use that without being an expert or knowing anything about cars. All I know is just driving it. But I use that as an example because I know that cars are uniquely identified by VIN number. And obviously, unless you falsify it, you cannot, exactly what car you're driving. The same thing with RFID. It has a unique number. It can be the same product, 2 products, exactly the same. They have 2 different numbers. And that's how we identify those 2 products. So if one leaves, we know exactly what left. And it's kind of a unique. And again, that can be protected based on how you want to protect it. And the information stored there is not sensitive information. As Rich said, we store like encrypted number that just doesn't mean anything to anybody. But once it connects to a database, the database handles the rest.
Yeah. So all the metadata lives in the Zemelgo solution, right? And so you put the VIN on your chemical or your calibrated equipment or your pallet, then you sort of describe what does this VIN represent, right? It represents a pallet of this item with an expiration date of 6 months, right? And so that's the metadata that gets pushed into Zemelgo. And when that tag is detected, we sort of rely on that metadata and the business logic to figure out, should somebody be notified, if this is expiring or if it's going into like basically the wrong area. So there's also even things, we have customers that have certain chemicals that shouldn't even be in the same cabinet. It's a safety issue. And so, if you have them tagged, we can alert you immediately if 2 items that shouldn't be near each other are like in the same cabinet, right? And so the point is, there's really no end to the business logic or what the software can do. Once you start to tag your items, there's no end from a software standpoint of the rules and alerts and sort of the AI recommendations that you can get.